Welcome to our presentation on comparing programming paradigms. We'll compare various programming paradigms, highlighting their strengths and weaknesses. This understanding will help you choose the right paradigm for your specific needs. We're going to look at the procedural programming, the functional programming, the parallel and concurrent programming, the imperative programming, the object-oriented programming, the logical programming, and we have to choose the right paradigm accordingly. So a programming paradigm is a fundamental style of computer programming that provides a distinct approach to structuring and executing codes. It defines the methodology and techniques used for writing and organizing programs. This is actually a recap of what we did in other lessons. We have the procedural, the functional, the parallel and concurrent programming, imperative, object-oriented, logical programming. Let's start with procedural programming. So as a definition, it focuses on sequence of procedural steps or commands to solve a problem. Programs are structured as a sequence of instructions. We have two key characteristics. We have the procedural programming, which is based on the concept of procedure calls, and it's structured as sequence of instructions or commands. What are the advantages? The simplicity first, the efficiency and the control. So the simplicity makes it easy to understand and implement, especially for beginners. It's efficient because it's often more efficient in terms of memory and execution speed, and the control because it provides a high degree of control over hardware and system resources. What are the disadvantages? We have the scalability, modularity, and reusability. So it's difficult to manage larger code base as the program size grows. It lacks modularity, which makes code's reuse and maintenance challenging, and code reusability will be limited compared to other paradigms. Some real-world examples, the operating system. There are key functions like the memory management, process scheduling, and file system operation. They are all carried out through dedicated procedures. These procedures will handle tasks such as allocating memory, scheduling processes, and managing file access. And we have the low-level programming that are commonly used. So the procedure programming is commonly used for level programming, such as device drivers development or embedded system programming. The functional programming. Again, we will look at the definition. We'll go through advantages as well, and some real examples. So by definition, paradigm that treats computation as the evaluation of mathematical functions, we consider it as functional programming. With this, we avoid changes in state and mutable data. We have three key characteristics: immutability, first-class functions, and recursion instead of loops. So in the immutability, variables do not change after being assigned. As the first-class functions, functions can be passed as arguments and returned from other functions. And we have recursion instead of loops, which is better for iteration. What are the advantages? We have two advantages: the predictable code and the facilitate parallel programming. So predictable code, because less prone to errors due to immutability and lacks of side effects, and immutability and stateless makes it easier to execute in parallel without conflicts. What are the advantages? We have also two: the steep learning curve and the less efficient for state-heavy stacks. It can be difficult for developers accustomed to imperative or OOP paradigm to grasp functional programming, and tasks that require frequent state changes like GUI applications can be cumbersome to implement using the functional programming. Some real-world examples we have in the finance and in the telecom. In the finance, it's used by banks for building risk analysis system because it has an immutable and declarative nature which helps avoid errors and ensure consistent calculation. In the telecommunication, it's utilized to develop a highly reliable and concurrent communication system. Its functional nature and support for concurrency makes it ideal for handling numerous simultaneous connections. The third is the parallel and concurrent programming. So by definition, it's a paradigm that focuses on executing multiple operations simultaneously. We have two key characteristics: the threads and process and the synchronization. Execution of multiple threads and process for concurrent tasks, and mechanism to avoid race condition and ensure consistency is the synchronization. So what are the advantages? Two advantages: performance improvement, it's efficient use of resources and reduced execution time for computational heavy tasks, and the scalability because it can handle large volume of data and multiple users efficiently. What are the disadvantages? We have also two: the complexity in synchronization. So managing threats and avoiding race conditions can be complex and error prone, and difficult to debug and test because concurrent programs can be challenging to debug due to its non-deterministic behavior. Some real-world examples, the big data and the video games. So in the big data, because it's utilized to process large amount of data efficiently through parallel execution, and in the video games, because games use parallel programming to handle multiple game elements like physics calculation, AI, which will provide simultaneous smooth gaming experience. The fourth is imperative programming. By definition, it's a paradigm that uses statements to change a program state. We have three key characteristics: the sequence of controls because the execution of instructions in a specified order, and the use of variables and mutable states, as well as the loops and condition because the use of loops and condition structure is one of its key characteristics. We have two advantages: easy to understand and start with because it's a straightforward approach that align well with human thought of a process. It's suitable also for simple sequential tasks because it's effective for scripting and automation of tasks. However, we have two disadvantages: the difficult to maintain on a large scale because code can become complex and hard to manage as the size of the program will grow, and we have a prone to error due to mutable state because state changes can lead to bugs that are hard to trace. Some real-world examples, we have the system management as well as the system software. So system management is used to task automation in Unix Linux system management. It's a straightforward nature that helps or simplify repetitive and simple tasks like the backups and software updates. And the C, which is one of the most common used of iterative programming, it's commonly used as well in developing OS and embedded system. We have direct hardware manipulation and performance that are both crucial. The object-oriented paradigm, it's a paradigm that organizes software as a collection of objects that encapsulate data and behaviors. Three main characteristics: classes and objects, which is a structure that combines data and method; inheritance and polymorphism that we saw in other videos as well; ensure code reuse and flexibility; and the encapsulation, which is hiding internal details of objects. Some advantages, we have two: the modularity and code reuse, and the facilitation modeling of real-world problems, because object-oriented programming promotes code organization and reuse through the inheritance and polymorphism. And the objects represent real entity words effectively, which will facilitate modeling of real-world problems. What are the disadvantages? We have also two: additional complexity for simple projects, because when you introduce classes and objects, it may introduce unnecessary complexity for small or simple applications. And we have the performance overhead because abstraction can lead to performance due to additional layers. Some real-world example, we have the web applications and the game development. In the web application, it's used by companies to develop robust and scalable web applications like streaming services. Modularity and code reuse will make it ideal for large software projects. And in the game development, because it's used in game engines like Unreal Engine or Unity Engine, where complex object interactions and real-time performance are crucial. We have the logical programming. By definition, it uses formal logic to express relationships and solve problems program that consist of a logical statements and rules. Two key characteristics: the formal logic, because programs use formal logic to express relationship and constraints, and the logical statements and rules, where programs are built from logical statements that are called facts and rules that are relationship and constraints. Advantages, we have two: the problem solving, because by natural approach for solving complex logical problem is the logical programming; and the expressiveness, because it can easily express complex relationship and constraints. However, of course, we have disadvantages. We are going to go through two: the performance, because it may suffer from performance issues due to the overhead of logical inference, and the control, it provides less control over execution flow compared to other paradigms. Some real-world examples, we have the expert systems and the NLP, or natural language processing. So it utilizes formal logic to represent expert knowledge and rules that facilitate complex decision making. Some example could include medical diagnosis system and financial advisory tools. And we have the natural language processing, where it applies logical rules to interpret and generate human language that enable tasks like text parsing, semantic analysis, and automated transition. Let's choose the right paradigm. What are the factors? We have, first of all, the project requirements, because different paradigms are suited to different types of problem, like functional programming is excellent for mathematical and data transformation tasks, while OOP is better for applications that model real-world entities. If the project involves handling large volumes of data or require high concurrency, you go through parallel programming, which would be a better choice. Another factor is the team expertise, because this plays a crucial role in how you will be developing. So choosing a paradigm that aligns with the team's existing skills can lead to faster development and, of course, fewer errors. For instance, a team experienced in OP, it might be easier to work with Java or C# rather than learning Haskell. Some paradigms like functional programming have a steeper learning curve, which will you have to consider whether the team has the time and resources to invest in learning this paradigm. A third factor is the performance need. Imperative programming can be very efficient for low-level system tasks, while functional programming can be less performant in scenarios requiring frequent state changes. So concurrent programming can maximize, for example, the resource utilization, which is very crucial for applications that need to process large data sets or handle many simultaneous users. As a summary for this lesson, we went through procedural programming that offers simplicity and efficiency, that provides control over hardware, but have some challenges with scalability and modularity. The functional programming is better for task requirement, high reliability, and low error performance, but less efficient for state-heavy tasks like the GUI application. Parallel concurrent programming is ideal for computation-intensive tasks and large data processing, but very complex to manage and debug. Imperative is very effective for simple automation and scripts, but can become very difficult at scale and prone to state-related bugs. The object-oriented programming is excellent for complex, large-scale applications where you require modularity and code reuse, but may add unnecessary complexity for very simple projects and impact the performance as well. And the logical programming excels in solving complex logical problem and expression relationship using the formal logic, but of course may suffer from performance issues due to the logic inference and complexities, and provide also less control and execution flow.